A resting neuron's plasma membrane is polarized. When a neuron is polarized, there are fewer positive ions inside the cell than outside the cell. In other words, the inside of the cell is less positive than the outside. Two important ions are sodium and potassium. In the cell's polarized state, potassium ions are concentrated inside the cell membrane, and the sodium ions are concentrated mostly outside the membrane. The interior of the cell has a charge of -70 millivolts when it is resting. When a stimulus is received by the neuron, the sodium gates open and sodium rushes into the cell. The neuron is now depolarized, meaning the inside of the cell is now more positive than the outside. The voltage of the cell when it is depolarized is around -50 millivolts. If the stimulus is strong enough, the graded potential activates the neuron to initiate and transmit a long-distance signal called an action potential. At this point, the voltage is positive. Once an action potential is initiated, it will travel the full distance to the axon terminals. After an impulse is transmitted, the neuron must go back to its resting state. Repolarization resets the cell to its original polarized state. The membrane's permeability changes again, allowing potassium to diffuse out of the cell. The neuron returns to its polarized state in which the inside is negative compared to the outside. At this point, the charges are reset. However, the ions are misplaced and must be switched. The sodium-potassium pump restores the ion concentrations with the help of ATP. 3 sodium ions are pumped out of the cell membrane and 2 potassium ions are pumped in until the ion concentrations are back to normal. The action potential is now on its way to the axon terminal.